Section 12.2 has to do with nets and surface areas. A net drawing is basically taking a three-dimensional figure and drawing it two-dimensionally, like taking a box and cutting all the edges in such a way that it can be laid, not flawed, but flat. Okay, so basically this is a box unfolded. Now, you are not going to be responsible for doing net drawings, but some of you might find net drawings easier to find surface area with. So it's going to be up to you. So surface area is really what this section is about, and it's the sum of the areas of each face of a solid. So if you look at this, this is going to be a triangular prism. So basically, you've got something like this, okay? It has a triangle on the top and the bottom, and it has three sides that are rectangles. So top and bottom are going to be the same. So that's going to be the first thing we find is the area of the top and the bottom. Now notice, and we'll look at the bottom, okay? Basically, this says this is a right angle. So if you remember right, it's 1/2 the base times the height. So 4 times 3, I know it doesn't look like this in the drawing, but there's your right angle. So this is, the top is 6, the bottom is 6. Okay, so we've got, that's the area, because you're going to take 1/2 the base times the height. That's the area of the top, the area of the bottom. Then you have this side over here, which the height is 6, so that height's going to be 6. So that's going to be base times height, so that's going to give me an 18 right there. And of course these are inches squared. Okay, and then if I look at the back, I have 6 is the height, 5 is the base. So this right here is going to be 30 inches squared. And then you've got this side right here, which is a 4 times 6, which is going to be 24 inches squared, 6 times 4. So then I would just have to add up each of those individual things. So I've got 30 plus 18 plus 24 plus 6 plus 6, and that's going to give me a total of 84 inches squared. So in other words, you're doing each one of them individually and then adding them together. Okay, so that's going to be a triangular prism. Okay, so if I'm looking for the surface area on this one, I've got, this is a triangular prism as well, because those are your bases right here. So I've got, the bases are triangles. Okay, now be careful here. Oh, well, they gave you the base and the height. Okay, so I have 1/2, 4 times 1.6, so 0.5 times 4 times 1.5, not 1.6. So the bases are 3 and 3, because the bases are always going to have the same. So this is 3 centimeters squared, this is 3 centimeters squared. Now the bottom here is going to be 4 times 6, so that's going to be 24 centimeters squared. Now to get this side right here, I'm going to have to know this measurement right here. So I'm going to do Pythagorean theorem here. So I'm going to take half of 4, which is 2. So I have 1.5 squared plus 2 squared is going to equal this x squared. Okay, so 1.5 squared plus 2 squared. And then I'm going to take the square root of that, and I'm going to get a 2.5. So this side right here is 2.5 centimeters. So now I can do this front right here. So I have 2.5 times my 6. So that's going to be 15. So the bottom is 24. This front is 15. And that back is going to be the same, because that's going to be 2.5 and that's going to be 6. So I have this side right here is 15. It's kind of hard to show you, but so this front is 15, the back is 15. I'm looking to see if I don't have anything that's like that. But so if you add them all together, you've got a 15 plus a 15 plus a 24 plus a 3 plus a 3. So I have 60 centimeters squared. The hardest part about this is trying to visualize it, okay? You're looking at something that's two-dimensional and you're making it into something that's three-dimensional. All right, your homework is on page 646, 15 through 23 all, and that's all about finding the surface area.